Welcome to this PragmaDev Tracer presentation. PragmaDev Tracer has been developed in the framework of an Artemis European project called Presto. The main goal of this project for us was to verify properties on traces. In order to easily verify the properties on the traces, we first thought it would be nice to use the same type of diagram for the traces and for the properties. For the trace diagram, because of our technical background, we focused on the International Telecommunication Union International Standard MSC message sequence chart. It's a very easy to understand diagram on which you can view the different lifelines, the states, the messages exchanged, the operation calls, and you can even look at the semaphores and timers. An MSC can also be used for specification. A specification is an expected behavior for the system. It can be a basic sequence of events, or it can contain alternatives and loops. It can also contain time constraints. In the example here, you can see that when instance 1 sends M1 to instance 2, instance 2 can either reply M2 or M4. It's a basic alternative. What about the property we want to verify? A property is a way to express causality. If a cause or not a cause, then an effect or not an effect. In the example here, for example, we could say if M1 is sent from instance 1 to instance 2, then M2 is right, but M4 is wrong. To express the properties, we use the property sequence chart. It's a basic set of notation on top of the message sequence chart, and where you can say if that sequence of events occur, this is right or wrong. Now let's get to the tool, to the new PragmaDev Tracer. Traces can be created online through a socket or offline through a file. You can also create a diagram from scratch. A diagram can be a property or a specification. Of course, you can open existing diagrams to edit them or publish them. Once you have defined your properties and specification and gathered all your traces, the tool offers three levels of verification. The first one is a basic comparison between the traces. It's like a basic diff. Second, it can verify the traces against a specification. And third, it can verify a property on the trace. In order to easily generate the traces, we provide a set of C macros that can generate online traces through a socket or offline traces in a file. This is very handy to generate traces out of legacy code. Let's have a quick demonstration now. This is the main window of the tool. First, we will trace live from a socket. As you can see in the main window, the socket is open on port 50002. This is of course configurable. As a fake executable to trace, we will use a Python program. As you can see here, it basically opens a socket on port 50002 as a client and then sends the commands to trace. Now let's run our Python program and see how the trace behaves. This is the resulting trace we get live. Let's close this down and move to property verification. Let's open a diagram from the history. This diagram is a basic specification. It says that if instance 1 sends M1 to instance 2, then instance 2 replies M2 or M4 without specifying if that is right or wrong. Let's now open an execution trace of that system. Both diagrams open in the same window. We'll tear off the tab in order to create a second window. Let's verify the trace is conform to the specification. We will go to the Diagram menu and to the Compare Diagrams sub-menu. In the Compare window, we will specify we are matching a trace against a specification. The tool says the diagrams are matching. Let's now open a property for this system. To define the properties, the property sequence chart notation is used. In that case here, we can see that if instance 1 sends M1 to instance 2, then when instance 2 replies M2, the property is right. But if instance 2 replies M4, then the property is wrong. The prefix E before the message name means regular. For a property, it is like an if. The prefix R means required, and the prefix F means fail. Let's now verify our property on the trace. The tool says the property is violated, and that is because M4 has a prefix F meaning fail. Okay, let's now have a look at another type of property. Now this one is a bit more difficult than the previous one. It says that if A sends M1 to B, then A should send M3 to B, except if M2 has been sent from A to B. So that's an if then except property. Let's verify that property on an execution trace. In our example, the tool could not match any property. That is because M2 was sent between M1 and M3. In that case, the preconditions of the property are not met. Let's now modify the trace and change the value of message M2. Now the tool says the property is matched. That's because M1 is followed by M3 and there was no M2 in between. The good news is that the tool is available for free. Just go to our website. Go to the Product and Tracing submenu. Well, now it is your turn to verify properties on your traces. Thank you for your attention.